Alright, so I'm going to give you a quick run through on what you should have got out of yesterday's lesson and just make sure that you have everything that you need regarding variables in an experiment. So this is stuff you've seen before, but we're going to just again make sure you're comfortable with it because these are things we use throughout the year when looking at our experiments in a chemistry class. So independent variable is sometimes referred to as the manipulated variable, in that that's the variable that you can change. And we can abbreviate that as IV, and again, how we can define this, and I'm just going to write it simply as change. So this is the variable that you can do something to it. So in the experiment, what are you doing as a scientist intentionally? So it depends on the type of experiment that you're running and the type of data you're wanting to collect, but you can change two things. You can change your amount, or you can change type. So you can change the amount of water a plant receives, or you could change the type of fertilizer a plant receives. So that's two different ways that you can change something intentionally in an experiment. So when it comes to where in the world do we graph these, when we put this onto a graph, the independent variable is always your x-axis. So then on the flip side of it, when you're running an experiment, you then need to measure something. That's what's responding to your manipulated or independent variable. So we can abbreviate that as dV. And so this is the variable that you can either observe or measure. Again, this one varies based on the type of data you're collecting. So if you're doing something with plants, you can observe or count, say, how many fruit it produces, or you can measure its height. So again, because of you changing something, you can go along and measure that. So what can I do with them? Well, nothing. You cannot change this. The only thing that you are allowed to do with this is collect the data. So then we put that on the y-axis. Okay? So a controlled variable, so the last two parts of an experiment are a controlled variable and constant. These things are not the exact same. And I think a lot of times they get confused as being the same thing. So a controlled variable is CV, and this is a variable that we compare to the independent variable. So a lot of times especially medical trials, when you're testing a new medication, you may have heard of a placebo or maybe like a sugar pill. And so a lot of times you'll have two groups, more than that, but we'll just simplify it as an A and a B group. So you would have group A that's maybe trying out a new medication to treat migraines, and group B thinks that they're getting the exact same medication, but all they're getting is a pill that's a sugar pill. So it has nothing in it in terms of the medication. So you can look and see, is that new migraine medication doing anything for those headaches? And so we're not going to worry about what we can do with them, and we're not going to really worry about what we can do with a graph. Okay? So on the flip side of that, another component of a well-designed experiment is that you should have things that are constant, and there is no abbreviation. So this is NA. So what is a constant? These are conditions, and let me change my pen color real quick. So this is, these are conditions that remain the same. Okay, so these are, no matter where you're at in the experiment, no matter how many trials you're running, these are things that should stay the same from trial to trial to trial. So let's say if we are doing an experiment on designing a migraine medication, you're going to give your different groups the same dose each time. So maybe it's a 10 milligram tablet or something like that, that you want to make sure that they're receiving the same amount of the dosage, and maybe taking it the same time of day or with the same frequency. So the control group is that they are not getting the medication but a constant would be things that are staying the same from trial to trial. So these are things we must keep the same. And you don't graph this. You only use your independent and dependent when developing your graph. So the next thing we're going to look at just real quick is a scenario in which we have an experiment and we can kind of pick it apart a little bit. So in this scenario, we have a student that's about to grow a plant, and so he's adding different amounts of fertilizer to 4 identical pots. Each is containing 4 pieces of seeds in 100 cubic centimeters of soil. All the pots were placed in the same sunny location and received the same amount of water. The height of the plants was measured and recorded for 5 weeks. So if you were the one conducting this experiment, what were you intentionally changing? That is your independent variable. That is what you are manipulating. So from the looks of it, what this person was intentionally changing was the amount of fertilizer. And note that it's sometimes good, especially if you're trying to replicate, let's see here, let's see if I can spell this right first. If we backtrack, that a lot of times we also want to replicate an experiment, and so we need a unit of measurement as well. And so it doesn't necessarily give us an exact unit, but what they are using as their judgment of amount is drops. So how many drops of fertilizer this plant is receiving. So the dependent variable is then what are we measuring as a result of it. So you change the amount of fertilizer, what are we then measuring? And it looks like it's going to be the height of the plant. Now this particular scenario wasn't very specific, so we can just kind of rough estimate what they might measure plants in. So I would say maybe centimeters from a science perspective. That might be a useful unit of measurement, or maybe even a meter depending on what you're growing. So the control variable, this is your placebo group essentially. This is the one that's receiving no treatment. So the treatment was fertilizer, so therefore the control variable is going to be the one without it, and so that is plant A. And what's so special about plant A is that there is no fertilizer. And so there's no unit there. So constants, if you read through the scenario up the top and look at the diagrams, there's lots of things that are constants. So you can probably come up with a wide range of lists. Some common ones I can see is the light amount, the amount of water, I would say the type of soil, and they also mentioned the volume of soil, the 100 cubic centimeters, so amount of soil. You would want to be growing the same plant type or same species. So you probably are getting the point here. So it's things that in every single container or scenario are things that should be kept the same. So there are, depending on the experiment, the amount of constants you have may vary depending on what you have going on. So I hope this video helped give you, again, just a quick summary on what's the difference between our different types of variables.